Welcome to the Tech Trends Podcast, where we discuss the latest manufacturing, technology, research, and news. Today's episode is sponsored by Modern Machine Shop Made in the USA podcast. I am Ramia Lloyd, and I'm here with...
I'm Elissa Davis.
Stephen Lamarca.
What's up, everybody? I'm Benjamin Moses. Guys, let's talk about hot topic. EVs versus hybrid.
Okay. I have very strong opinions on this. Partially because I've always wanted a Prius. Okay?
Sure,
Toyota Prius.
sure.
I only drive Toyotas because they're super reliable, insurance is low,
Yeah.
and all those great things.
Which, by the way, the new generation of styling looks really, really hot.
Yes.
I
They're
want
gorgeous.
a 4Runner so bad.
Ooh.
Forerunners
Toyotas are so pretty.
My sister has a 4Runner, and they're really...
I
Because
feel
she
like
got a
it's-
massive payout during COVID when she got into an accident, so like, she was able to...
It's like right in between like a Jeep and like a Bronco, but like where you actually feel like you
It's
won't
huge.
die if you get into a car
It's huge.
accident.
Also,
you know?
4Runner is like an heirloom piece where you can pass that car on for generations.
It's
and it'll
gonna
last
stay
years.
sturdy, yeah.
Well, it's the same thing with like a Corolla. Like,
Yes,
because I
yes.
drove my parents' 2012 Corolla until 2019.
Did you know that like one of the most popular modifications for a Toyota 4Runner is to EMP proof them? Because they're that reliable. Like if a nuclear explosion
Oh.
goes
For end of the
an
world.
electromagnetic pulse will
Interesting.
follow to wipe out all electronics, and you can EMP proof stuff. I don't know how valid these parts are, but people do that because they know the 4Runner's
It's
making
gonna
it through a
stay.
nuclear
See?
apocalypse.
See, I need that.
So at the apocalypse, there'll be cockroaches and 4Runners
Yeah.
all over the place.
Like people like,
Yeah.
like the biggest downside to having a 4Runner is it burns all of the gas.
Yep.
And it makes no power or torque. Super low performance, high fuel consumption. But the trade-offs to those awful things, they're bomb-proof. They are literally bomb-proof. Like Top Gear has tested the Toyota Hilux, which is what the rest of the world calls the 4Runner, and they've dropped it off a building. they've chained it down with boat anchors at low tide and let the tide come in and totally flood the car, and it still starts. Like, these things are obnoxious.
Yes.
Well, let's get back to
Well,
EVs
okay,
versus
yes,
hybrid.
but Toyotas,
yeah.
yes. Obviously,
Get away from gas.
we should just say that Toyota is a great manufacturer.
Sure.
And anyway, but when I was looking to buying a Prius in 2019, when I bought my Yaris, I was looking into buying a used Prius because I was like, okay, it's gonna be a little bit cheaper. I can afford that. And when I was looking at used Priuses, this is before like COVID and everything, right? So
Some
when
would
I
say
was,
pre-I.
when I was looking at used Priuses, they cost the same amount of money as like a brand new Corolla, and they were like 3 years old,
Right.
right? And I'm like, dang, but I would really like a Prius because, you know, they're quiet, they have great gas mileage, you know, and then they're hybrids,
Yep.
right? So I know that like a lot of people are making the switch to like EVs, and a lot of major car manufacturers are creating more and more EVs.
Blood diamond on wheels.
But I also know that like from like MT Forecast and like the different presentations there, that people just keep running into problems with the batteries.
Right.
They just keep hitting these walls with batteries, right? So why are we focusing so much time and money on creating EVs instead of just creating more affordable, accessible hybrid cars?
Yeah, that's an interesting conversation because both the whole life cycle of after you buy the car, but also like the manufacturing side of it and the ecosystem of batteries versus an EV, or I'm sorry, a full battery versus a hybrid. It's very, very interesting that the shift to all EVs, like it still seems like a not quite emerging technology, but a technology that still has tons and tons of problems with
Yeah.
Right. Well, I mean, as we know in the manufacturing industry how efficient electric motors are. There's not a single gas engine on a single machine tool. Like they're all electric motors. We've got electric motors down, but internal combustion engines we've been using on a consumer scale for 100 years or more. We've perfected it.
Yeah.
This is an analogous discussion to additive, the sustainability of additive versus conventional manufacturing. Sure, additive, you can use the exact amount of material that you need when you're making a part, but it's still such an early technology that there's still going to be a lot of waste.
Right.
As for, waste is almost the name of the game when it comes to subtractive manufacturing, but the workflow and the supply chain of subtractive manufacturing has been around for hundreds of years, that we've figured out how to not waste the scrap. Scrap is not synonymous with waste. Like, it's all recycled. And EVs there's still a lot of work to do.
Yeah.
I mean, I am not anti-EV. I love
No,
EVs.
yeah.
And I don't think anybody here is. I'm anti-battery. Like, children in Africa need to stop dying to mine battery material for us to have a new car that we're just going to, the common American replaces in less than 10 years. That's gross.
Have you seen a Cybertruck? All right, I'm sorry.
The dumpster on wheels?
I'm sorry. Like, I'm sorry if you drive a Cybertruck, but like, you look ridiculous.
Have you ever seen one in person?
Yes,
Yeah.
I've seen like 4.
I have
Oh
one in
my
the neighborhood
God.
now, and I jokingly, but not jokingly, said to the owners, like, you're bringing down our property values.
There's a tweet that I keep seeing, and it's like, no matter how bad a day I'm having, it's okay because I do not have a Cybertruck. Like, I just.
Well, but we also got but on the like same note with like Tesla, in China, Teslas have been recalled like dozens of times.
Yeah, China is like, these things have problems.
Yeah.
And you know,
Maybe they're more strict than we are, and I get that, but also like, I remember when I bought my Yaris, and we were talking to the dealership guy about like electric cars, and this is early 2019, and so like, you know, Teslas were out there, and this wasn't that long ago, but he was talking about like how, you know, these batteries, like he's heard horror stories of people's batteries like blowing up their cars or like overheating, or
to be fair, any stored form of energy will, if releasing that energy happens improperly, it is catastrophic.
No, yeah, but we haven't perfected the EV yet. So why do we keep doing that instead of focusing more
Haven't
on the
perfected the
hybrid?
battery yet.
Yes,
Yeah.
that's what I mean.
And I do think there's two kind of intersecting issues that run into. So the early stage companies that are getting aggressive. So like Tesla is still a fairly early stage company. So for them to get over their learning hurdles about product quality, design, so there are not a lot of failures, that's kind of accelerating the issues around battery or EV cars in general. But also, I really like the concept of alternative combinations between the two.
Yeah.
So we're very comfortable with the internal combustion engine, you know, powering most of the car, and then the battery / motors complementing it or just running on like 10 miles of range and stuff like that.
Right.
There's been a couple of new scenarios where the engine actually powers like a really, really small battery, and you're just using motors to power the vehicle itself.
The Chevy Volt.
Right. So you're using the, you know, IC as a power generation source just to power a small battery, which reduces the battery size, to your point, Steve,
Yeah.
of let's not build these massive batteries and then figure out what to do with them later, right? Let's build these smaller ones that if there are issues, you can change them out and have a better life cycle for them.
The EV market has created a economic battle over natural resources again, and it's like we are so beyond that as a civilization, as a species. Like, really, we're fighting over natural resources. Gross.
So I do want to mention, because we were talking about like battery storage and stuff like that. So long time ago, when I was a youth, back in the early 2000s, I was a giant bass head. So I had a Volkswagen Golf, and I wanted to get into audio in a Volkswagen Golf. So I was like, I'm going to see how many speakers I can fit in my car. So I had two 12-inch subwoofers that could run on 1,000 watts each. So I was like, the engine's not going to run this, so I need a capacitor. So back then you had a capacitor that could run those speakers. Otherwise, you would pull too much amps from the engine. Your engine would actually shut down.
Yeah, you're going to kill your battery. You're going to kill your alternator.
So we were talking about this earlier, but capacitors are measured in usually millifarads.
Microfarads.
I had a 1 farad capacitor in my car.
That is.
I had the early days double battery in my car. It was amazing. You could kill someone with that.
12 volts at 12 volts at 1 farad is insane.
That also explains why I can't hear very well at my age now.
And that's a frequency that made you deaf that you can't even hear.
Exactly.
Like, that's like being blinded by IR light, by IR lasers. Like, you don't notice that you're being blinded. You don't get a spot in the middle of your vision, but your vision's going to go away.
Yeah.
But like, to your point on capacitors, like, you know, just to clarify the difference between a battery and a capacitor. A battery charges slowly and releases its energy slowly, but can hold that charge, can hold that energy for a longer period of time with more stability. So like it stays charged for longer. They slowly discharge over time due to environmental characteristics, but a capacitor, you charge it up, and once it charges very quickly, but once it's fully charged and you remove it from power, it starts to drop pretty quickly. But the beauty of a capacitor, not only does it charge quickly, it can dump that energy like that.
Right.
So it works in something like a demanding audio system. But that makes capacitors all the more of a viable energy storage device for something like a hybrid, where power can be generated on site.
Right.
And this is why hydrogen EVs or hydrogen vehicles are so important. It's an EV.
Right.
It just doesn't have a battery. It has another new tech that's not relying on natural resources
Well,
as much.
okay.
As much.
Hydrogen's a natural resource. Let's not forget about that.
Yeah, but you can create it.
Fair.
To bring it full circle, do you want to know what car has a great bass?
We've come full circle. Nicely done. So, Ramia, can you tell us about today's sponsor?
Yes. Tune in for Modern Machine Shop's Made in the USA podcast to explore manufacturing issues faced by companies making an intentional choice to manufacture in the U.S. Featuring commentary from OEM leaders, Made in the USA blends its nearly century-long expertise with a unique audio storytelling experience to shine a spotlight on the past, present, and future of American manufacturing. Find Made in the USA on Apple Podcasts, Spotify, and all major podcast platforms. Follow Modern Machine Shop on Twitter, Facebook, and LinkedIn.
Thanks, Ramia. Steven. Testbed, robotic arm. We're doing things.
We're doing so many things.
You're doing things.
Not really that many
so
things,
many
but
things.
we're doing things really well now.
Okay.
Like I've got technically 3 programs, but 2 important programs that I've successfully written for the robot arm to open and enclose the Pocket NC's enclosure. And I'm confident in saying that they are at least 90% reliable.
And I do want to hit on, because it's fairly complex because it's not a sliding door, it's a rotating door.
Yeah,
so it's
rotating
the pivot
upward.
And it's a little bit of a tight compact. We did it on the singularity issue that we ran into for a while, where it's a compact arrangement because the robotic arm has limited reach.
Yeah.
And it's both tight and the
the
weight.
window of range is so narrow.
Right.
Because you were going, and I cut you off, I'm sorry. The Pocket NC can't be too close, because if it's too close, the robot arm can't get compact enough to reach the door handle when the door's at its closed low position. And if it's too far away, then it can't reach the door handle when the door's open.
Right.
It's up and high, or it's high and far back.
Yep.
So we found this nice little window.
Yep.
But it's been a headache with the programming. And so I think the last episode I was talking about how we figured out how to get around singularities and the complex math of, the singularity. We've gotten around the singularities of linear motion by doing either circular motion or joint motion, and we've kind of written off using circular motion because the math is tough. But the joint motions work really well, but because there are so many motions, they're like so many little checkpoints that you have to make through the path of travel of the arm, that it's constantly stopping.
Right.
And so this was obviously one of the most unattractive things of watching the robot do this, because it's like it's like dial-up modem of modern automation. But then I noticed in the XML code that there's a parameter that I hadn't adjusted, I hadn't modified at all, and that's called smoothing, and smoothing was set to 0%. So naturally, what do?
Turn it to 100.
Turn it to 100 on all of the motions. And then the robot's motion looks so smooth and fluid and organic, and it looks beautiful. But it overloaded the robot, and I heard the gears skip a tooth because everything's moving at once instead of being locked in one position and stopping every now and then. But fortunately, you can adjust the smoothing at every point. So basically, of the opening process, which is 44 lines of code, there's a short 5 to 10 line code window where I have the smoothing dialed back to 0%, where it's just going to
Yeah.
influence, to convince the door to open.
Yeah.
And we were also running into the gears skipping in that one particular joint 5 of the robot arm, because it was just overloading the max payload capacity of the arm. Fortunately, I alleviated that by loosening the 2 nuts in the hinge of the enclosure to reduce the resistance, and that helped a lot. And before we did that, we were thinking about removing one of the struts that holds the door open, because what the purpose of the struts, there's 2 things that struts do. Well, they dampen oscillations of force, but in doing that, it means the purpose of the struts is basically to make kinetic friction and static friction meet in the middle. So instead of 2 values of friction, now you just have a constant friction throughout the entire range. But that made it difficult on the robot because it has to work really hard to get the door to start opening. And when it's in kinetic friction, which is less than static friction, once it's moving, now the dampers are adding resistance to it. So, but the dampers are definitely needed because it kind of makes the door lighter when it's moving.
Yep.
That was a lot of physics.
I'm
words.
so sorry.
I do want to hit on another problem that we actually solved. So I designed on the fingers the V channel
That didn't help at
to
all.
pick up the round handlebar, but also pick up the raw material. So we're thinking about using the V channel to support both. And we realized in that circular motion to open the door, the V channel is actually binding a little bit and causing a lot of friction and overloading the payload. So we're able to rotate the arm, or rotate the last joint, the wrist, so the fingers were on the smooth part of it, the side of it.
Yeah.
And I think that was the kind of breakaway realization, is that it needed that smooth surface, the flexibility.
'Cause the smooth surface allows the door handle to slide back and forth on it. Because as gassed up as I am about my robot programming skills, they're not that precise.
So
They're not that accurate.
I think that's the key takeaway, is like allowing some flexibility in the design of it for some type of motion and flexibility. So I think, initially I was very excited about being very precise about it. But in going through the process, sometimes you need a little bit more fluidity or flexibility in the design. So that was a good takeaway. Also, definitely want to mention, as Steve is working through the automating the Pocket NC,
Yeah, tell them why this is necessary.
both Chloe and the rest of the team are working through the digital side of it. So getting the factory test bed to represent a factory in terms of getting data off it to get us to represent the digital manufacturing side of it. But the long-term goal is to look at what the next potential need in the industry is, and that's looking at open USD. So open standards for the representation of different scenes in manufacturing as we look at like potential digital twins or visualizing on the factory floor. So the overall long game is continue adding value to the industry of standard development using the test bed. So I think this is a very good parallel on terms of the physical side of representing a factory on the floor and being able to use the test bed to grow standards that's useful for the manufacturing industry. So very excited for that. Elissa,
Yeah.
give us some NASA and space news.
Yeah. So I love NASA. Just FYI, I love NASA. I just like space. I think space is one of the most fascinating things in the world. And I remember that when I read the book October Sky when I was in 7th grade, and it changed my life. And then I watched the movie with Jake Gyllenhaal, and it changed my life again for a different reason.
I do like the irony of your statement. The most fascinating thing in the world. Well, it's not in the world.
Yeah, in the universe.
Okay.
There's space in you right now.
Oh,
Yeah.
If we want to get all physical about it.
Yeah.
Let's get physical.
Energy doesn't disappear. So we're all made up of the same energy
Not
that
created
existed
nor
thousands of years
destroyed.
ago. Yeah.
Same as mass. Are they related?
So my article is about NASA awarding $3.8 million to recruit students into STEM. So they granted $3.8 million for its Minority University Research and Education Awards, which is MRIP. It's one of their divisions at NASA. So the institutions that were selected were Florida Atlantic University in Boca Raton, University of Central Florida, Orlando, Hartnell Community College District, Salinas, California, California State University, San Marcos, Texas State University, San Marcos. sorry, I just realized, is there 2 STEM markets? Is there one in Texas and one in California?
Probably.
Interesting. Tennessee State University and University of Hawaii, Honolulu, and University of Texas, El Paso.
Wow. That's a healthy list.
Yeah.
That's
so they all got about 480,000 basically.
Nice.
Some of them it's like $479,990, you know, but like the other one who got just like a Tennessee State University got 480,000 even. So
Who skimmed off the top?
but yeah, so these are all specifically to recruit different students to get into STEM careers as like more and more STEM majors are becoming available at these universities. Like more, I guess like more like specific STEM majors, right?
Sure.
So like things that are robotics specific or things that are aerospace specific or things like that.
I do wonder if this is very similar to manufacturing, where I think NASA and the government is looking ahead a little bit to see. They're seeing a significant growth in space exploration. Private industry, different companies, and we're seeing the manufacturing side of it growth also, where I think they're trying to get ahead of. I think they're going to hit a really big bottleneck in terms of supporting the space industry in terms of talent.
Yeah.
So it's an interesting look on parallel where manufacturing has a parallel growth, and I think we'll continue seeing that growth for a long time in terms of space manufacturing.
Well, if you've seen October Sky, at the end of the movie, he's recruited by NASA to science fair.
Oh,
So,
nice.
you know, bringing it back to October Sky. But I did also want to touch on that NASA did award $1.25 million to 3 teams for the deep space food finale.
NASA's all in the competitions
Yeah,
now.
which is these teams which are developing ways to make like food creation and nutrients sustainable
Nice.
in like space environments. So the winner was let me find this was the let's see the Interstellar Lab of Merritt Island in Florida, led by Barbara Belvisi. They combine several autonomous phytotrons and environment-controlled greenhouses to support a growth system involving a self-sustaining food production mechanism that generates fresh vegetables, microgreens, and insects necessary for micronutrients. And the 2 runners-up created...
Space bugs.
Yeah. The 2 runners-up created... So there was Nolux, a university team led by Robert Jinkerson, which is I love that last name. Constructed an artificial photosynthetic system that can create plant and fungal-based foods without the operation of biological photosynthesis. And SATED, which stands for Safe, Appliance, Tidy, Efficient, and Delicious, is a one-man team of Jim Steers who developed a variety of customizable food from pizza to peach cobbler. The product is fire-safe and was developed by long shelf life and in-situ grown ingredients.
That's fascinating.
Wow.
Yeah.
That's cool.
So I'd maybe think of the movie The Martian with
Yeah.
Matt Damon, where he has to grow his potatoes.
Ben knows
on
what this
Mars.
makes me think of.
What's that?
We're bringing bugs to space.
Yeah.
And back home on the planet Earth, we're all getting into AI. This is literally the beginning of the timeline of Helldivers.
We'll see in the future. I like where this is headed. Thanks for Elissa. That was great.
Yeah.
I've got one on industrial PCs. The reason I want to bring up industrial PCs, so we got
One new
something
graphics card.
from the yeah. I would love a new graphics card from the Robot Report. I'm talking about ruggedized edge computers, and the thing in parallel is for digital manufacturing and the growth of. There's just a lot more data on the shop floor. Right? How are we both processing it and also conveying it? And this article hits a lot on the need for that. And we actually just published an article about edge computing and being also progressing security in the factory. But edge computing is coming more and more relevant, not only for AGVs, which this article hits on, but back to robotic arms and vision systems and all the processing power required to make a decision close to the point of use. And that's kind of the big takeaway here is, their example on AGVs and AMRs, where they're looking at integrated real-time edge AI performance for robotic vehicles, AI processing, so not only for vision systems, but also LiDAR, radar, and all the other sensor fusions that they're incorporating on the device itself. And also it talks about IoT connectivity, right? So yeah, the edge computing is great, but it also has to convey information back to the fleet management software. So how does the software or anyone else know where that machine is and the health of that system? So that's a growing trend is now I need to worry about my IoT infrastructure in the factory floor. And then it gets into like the hardware itself, right? It's fanless versus cableless design, and you are listed.
How can it be fanless? Because I know, like, isn't overheating an issue? So how
Heat
does
sink.
it
It is.
work around it?
Thermal capacity. Throw metal at it.
Yeah,
Okay.
yeah. So passively cooling system with giant heat sinks. So that was a fun article, and the applicability not just for AMRs back to, if you're looking at vision systems, if you're looking at more robotic arms, any level of automation, to be honest. I think taking a step back and look at your IT infrastructure and how you're computing on the edge is definitely worth your time. And Steve, you've got some YouTube content to talk about?
Yeah, I saw this a YouTube video popped up in my feed one morning when I was struggling getting out of bed, and it worked out because this guy's channel, DIY with Dave, has a video called "The Decline of a Great American Tool Brand: What Happened to Craftsman Tools." And I just thought it was a fun topic, but it brought up some other keywords. But before I get into it, let me explain. Craftsman Tools is a classic tool brand since 1927. Were bought by Stanley Black & Decker in 2017. This is because Sears, who was the primary retailer of Craftsman tools, ran into some financial difficulties and went bankrupt. Sears basically no longer exists anymore.
Yeah.
They tried to bring some manufacturing back to the U.S. in recent years, but the factory that Stanley Black & Decker built, massive facility in Texas, closed in 2023. They blame it on the pandemic. I'm sure the pandemic had something to do with it, but could have also been, capitalistic corporate greed.
Amazon.
Tell
And while
us how
they,
you really feel, Steve.
Yeah.
but while
intense.
Craftsman as a brand still offers a lifetime warranty, they're currently sold, like their biggest retailer chain is Lowe's. They still offer a lifetime warranty on the older tools, but a lot of those older tools just like don't really exist. If you break, a crescent wrench that you had made by Craftsman from like the 60s, you're not going to get a new one.
Right.
And it's not, and the one that they give you is not going to be made in the U.S. It's going to be made in Taiwan, which is not bad, but it's just, there's a lot of nostalgia to the old made in the U.S. Craftsman stuff. And some fans who and tool owners of Craftsman tools are worried about the quality and the brand's future. But the video brought up because we talk about how Craftsman was vilified for a while from being this great American made in the USA brand to being like cheaply outsourced overseas and wherever. The attempt at that Stanley Black & Decker made at bringing Craftsman back to the United States, specifically to make these tools in Texas, that concept is one that we talk about a lot, at least the industry talks about a lot, which is reshoring. And Mr. Dave from DIY with Dave brings up how, reshoring, while it's great and it's going to be awesome, it would be theoretically awesome for our economy, there's some dangers to it. Like if you cut off certain countries that might not be as friendly to U.S. politics, that's really unfriendly. And so reshoring isn't always the answer. And he also talks about some other concepts of outsourcing and moving manufacturing around. And when I was discussing this with Russ earlier, he brought up nearshoring. So like a lot of car manufacturers, U.S. car manufacturers and Japanese for that matter, instead of building cars to be sold in the U.S., which a lot of foreign manufacturers actually do. There's a lot of foreign cars that are more American than American car brand cars. But that's called nearshoring, which means it's offshore, but it's near, like Mexico or Canada. And he brought up another fun term called friendshoring.
Friendshoring.
So, like, we're not the tightest with China.
Sure.
But we're tight with Taiwan and Japan. So let's move the manufacturing from China to Japan or Taiwan or somebody like that.
That's a fun term.
It's just something cool to think about.
I love it.
Friend zoning
Sure.
manufacturing.
Friend zoning manufacturing.
Manufacturing in the friend zone.
It is fascinating, like, the geopolitics related to manufacturing. I mean, to your point, Steve, like when Carrier moved from Mexico back to Texas and the whole controversy related to that.
Like the AC condensers?
Yeah.
No way.
There was a big controversy about them moving around a little bit. There's very interesting look at like these large corporations and how they're moving around the world. And I do like the concept of like friendshoring, but like the small contract manufacturing, I think they have a lot more flexibility. So being able to go to nearshoring or supporting what is their strategy and how fast they want to be in turning parts around, I think that's a lot of different options now.
Yeah. Wow. That's fascinating. I'm going to Google Carrier now because they were manufacturing for a long time in Mexico and they've since moved to Texas.
You should look it up. There's a story behind it.
Okay.
And it relies on the government at that time too. So
That's big because like those AC coils are heat sinks
Yeah.
and radiators, and that those are typically manufactured using a metalworking process called skiving, metal skiving. And metal skiving is not very common in the United States.
Yeah.
We typically leave skiving to East Asia, and somebody from the government recently reached out to me about metal skiving because he was worried about it being a threat to U.S. manufacturing and the supply chain. So
Here in America, we
this
do
is fun.
Thanksgiving.
that's bad. Yeah.
Thanksgiving.
Stop it. Stop.
Rumia, where can they find more info about us?
amtonline.org/resources. Like, share, subscribe.
Bing bong.